So we still have a few people trickling in, but we're going to go ahead and get started here. Again, my name is Drew Williams. I am the marketing manager for Kobiton, and I am joined by Henrik Rexed, the partner solutions evangelist for Neotys, and Frank Moyer, the CTO for Kobiton. And today we're going to be discussing the newest integration between Neotys and Kobiton, and specifically explaining a little bit about how you all can perform load testing on real mobile devices. And so with that, I'll go ahead and turn it over to the presenters and we'll get started.
So hi everyone, just one simple reminder before we start. It's GoToWebinar. You don't have the options to ask a question directly. So if you have anything, if anything is unclear or you have questions during the webinar, you can just type your questions within the question section of the GoToWebinar tool. Of course, at the end of the session, there will be a Q&A session where we will try to answer to most of your questions. This webinar has been recorded, so if you didn't have the chance to reach us today, or if you have a constraint that you need to leave before the end of this webinar, don't worry, this webinar is recorded, so you will have a link with this video of the recording. All right, so like Drew mentioned, today we have this webinar is presented by Frank. Hi, Frank, how are you?
Good, Hendrik, how are you?
I'm fine, thanks. So I think let's go directly to the section. So I'm just going to introduce me quickly, and I will leave you as well to the introduction. So my name is Henrik Rexed. So I'm Swedish, so I'm quite a Viking fan, but also I'm a Lego fan. So which I have lots of Lego figures and minifigures. So don't be surprised if you see Legos today during this webinar. I'm really sorry about that, but I've been in the load testing market now since more than 12 years now, delivering performance testing or services, and now today I'm more focused on bringing new technologies and helping performance engineers. So by building integrations or building new protocols for Neotys. So if you add the Viking plus the Lego, you will have my character that you can find in LinkedIn or Twitter. It's the Night Loader. So if you follow, you can follow me in LinkedIn and Twitter, of course, if you want to see some news.
Thank you, Hendrik, and thank you everyone for attending. Hendrik and I agree on a lot of things, but the Lego part is probably the thing that I have the most difficulty with. I broke my toe once stepping on a Lego that my child left out, and it's scarred me for the rest of my life. So, so my name is Frank Moyer. I'm the Chief Technology Officer of Kobiton. And I've been in the tech industry for 25 years. I've been the CEO of 2 startups that exited successfully and joined Kobiton about 6 months ago. Really enjoyed working with Hendrik and seeing the power of NeoLoad and the capabilities they bring, and excited to share with you combining that capability with using that capability on real devices. Kobiton, as Hendrik mentions, we provide real devices in the cloud for you to run performance tests as well as manual and automated functional tests using Appium. Thank you very much, and I'll be joining you again later.
All right, so I think I like to start to introduce webinars by reminding the fact that user experience is crucial. So I mean, nothing is new. Everyone is aware of this. Here, typically, it's a couple of stats that you can find in WP Stats, by the way, in fact. So a couple of references about how the customers behave regarding bad user experience. And I just selected 3 of them. So the first one is the importance of mobile device, and Frank's going to add more on that. People is now reaching more and more applications or website through their mobile device rather than their traditional browser. And also, if there is a bad experience, people are not afraid to move to the competition as well. So is no big news. Yeah, I'm pretty sure that everyone is aware of this. The main problem is when you have bad performance. I mean, if you talk to a project and most of the people will say, I got the best architecture, I got the best DBA, I got the best methods, I'm using DevOps or whatever it is, and I'm using the best cloud provider, I'm using the best framework of the market, and so my application is going to be robust. It's going to be the most powerful application of the market. But the thing is, every man or every application has a limit. I mean, if you're after a certain level of load, even if your code is the best one, something's going to break. And if it's breaking, then it's going to affect your user directly. And one thing before we continue on this, I think I like the quote of, one of the biggest leader of the industry, that Steve Jobs, where customer don't measure how hard you try. I mean, they don't care. I mean, they measure you on what you're delivering. So don't forget about this. Your customers don't care about how long you've been and the effort that you've been doing on coding your app. They're just gonna evaluate you on what they have in front of their eyes. So what is user experience? Well, user experience is a combination of several layers. In fact, the first thing is you got a feature. So that's why functional testing is more than important. If this feature is not there, then obviously, if I am not able to log into my portal, obviously it's a bug. I will be frustrated. So even if it's performant, even if it's nice, you need that feature. The feature is going to be the core element of the user experience. And then on top of that, you'll add a UI, which needs to be easy to use, needs to be nice, look and feel. And also, you don't need to be trained or get to a training class just to use the app. It needs to be really intuitive. And last, of course, is performance. And if one of those layers is not there, and especially performance, then people get frustrated and get a bad user experience.
So the next few slides, we're going to talk about user expectations, tagging on from what Hendrik said. And this was a survey done about a year ago by TechBeacon. And the expectation of users that users have today is that mobile applications respond for every transaction in less than 2 seconds. It's a little bit gray in those areas, but you can see that 7% expect less than 1 second, 14 within a second or at a second, and then 28% at 2 seconds. So there is an expectation for users to get a very responsive mobile application. Tagging on top of that, users have feel like their feeling towards a brand is significantly impacted by the mobile app delivered by the brand. So when apps crash or freeze or there's slow performance, they think negatively about the brand. Other issues that they have the other things that they are concerned about are battery usage, when user reviews are poor, and when the app uses an excessive amount of the cellular data, causing them financial impact. So that gives you a good sense of the impact that having poor performance or an unstable app impacts your brand.
Here is also another reference from WPOstats.org. So it's basically listing every performance studies that's been done by companies and over the last years. Here I selected 4 of them. I'm not going to explain them one by one because obviously it doesn't make sense. But what I like here is, I don't know if you're familiar, but it was a really popular study done by Amazon almost 10 years ago, in fact, where, and the study was, they came to one conclusion saying every time that Amazon response times were increased by 100 milliseconds, they were losing 1% of revenue. And what is funny here, I mean, it's not funny, but if you look at this slide here on the second reference with Walmart, it's about the same conclusion. Every 100 milliseconds improvement also resulted in up to 1% increase in the revenue. So there is a direct relationship between response times and revenue, especially for those public-facing applications. The thing is, what is complex here, we're talking about user experience here, and a lot of things has changed the last 15 years now on the way we are delivering websites, or I mean native app of course as well, but the way we measure response times has heavily changed. I mean, here I took a screenshot of Amazon 10 years ago, and on the right side you got Amazon of today, and you can see that something happened. I mean, it was nice design back at 10 years ago, and I'm not saying that the design was bad. Is that if you look on what happened the last years, it's just that the user experience has changed significantly, and we are helping our customers to click or to target the products. And what I also like is to show, I mean, if I show that to my kids, this website here, people will be a bit confused. I mean, what is this? Is this a real web page? I mean, come on. I mean, if you remember yahoo.com or Alta Vista, for those who were familiar to that, the website was exactly like this. I mean, it was really bad user experience. I mean, I'm pretty sure that if we give that type of website with a lot of frames, with a lot of GIF or things happening on the screen, people will be laughing. In fact, they will think that it's a laugh, it's a joke. But this is true. I mean, if things have changed on the way we deliver websites, and in fact, what is funny is this website, which looks really ridiculous with a lot of things, was much more lighter than the websites of today. And here, what I did, I extracted statistics that is available on HTTP archive, and I wanted to highlight the fact that today, because of the importance of the UI, importance of the user experience, our websites are becoming heavier than before. Today, one page is around 3 megs, 2.5 megs. We're going to reach 3 megs soon, potentially. And the number of requests per pages has just increased a lot compared to the old-fashioned way that we deliver information with a couple of JavaScript pictures. Now there's a lot of CSS, a lot of JavaScript, a lot of resources. So we are just increasing the number of requests that is required to just display something on the browser. And here I took the example of a single page application, how it's been loaded on the screen. And in fact, it's funny because it's really similar in a sense to a mobile native app, where the presentation layer, application logic, everything back in the old days were hosted on the server side. So the client basically were just getting those content and just rendering it on the screen here. And here things have changed, where we have sent the presentation layer at the client side, and this is exactly what happens with the native app. We have to also bring the logic of the application. It's on the code of the native app, and here in the case of the websites, it's going to be in the JavaScript. And now, instead of the first request when it comes to a pure web page, we are requesting for the structure of the page. We are getting a lot of JavaScripts, and then we start processing them, and we do a lot of requests to get some content and to start the rendering. So we are increasing the number of requests just to sort of update the UI of the screen. And this is similar to what to native apps. The other stat here, which is interesting, is also, especially in the web, it's the size of the JavaScript. It shows here the size of a JavaScript has been multiplied by almost 4.5. And this is just show the fact that we are bringing all the logic back to the client now, and it's same logic with, of course, with native apps. So with the way it's been rendered on the screen, it's quite traditional. When we send a request, we get some content from the server, and then the browser gets the structure of the HTML, and before he does, he is able to start rendering something on the screen. He needs to process the structure of the page, so the DOM structure. And once it's been processed, then you start rendering. And when you look at the way we've been doing load testing on the, since 12 years for me, but more than 12 years for me, but maybe more for the others, we are measuring a request and response. We are measuring the time to get a request and get the entire content, but we're never including the rendering piece. And this is even true and more important when it comes to mobile, and you will see that later. So here, if you want to report back efficient user experience, now today we know that it's important, then we need to figure out how we can do that. So if you look at a traditional native mobile application architecture, you have, so everything is the mobile reach the application or the infrastructure through JSON calls, so API. So potentially you have dedicated hosts for your mobile users. The web app, usually you have also some either JSON request or resources. So you're going to also have a dedicated nodes for that. So which means here, one architecture delivers all your clients. It could be mobile users, it could be browser users, it could be also third-party web services or REST services, whatever it is, just to deliver your content to a third-party websites or to a third-party application. So here, the main idea is, even if you are in charge of the native app and you have to deliver load testing, don't limit yourself on only mobile users, because what is important here when you do load testing is to have a realistic simulation where you bring all the traffic on the same test. And here it's one of the references that I have here is from one of our customers, which is it's a betting company, and it was a couple of years back. It was a European soccer tournament, which was really important, and that they're doing load testing quite heavily, and because they know that they need to deliver good response times if they want to take more bets. So they were testing that. So they were preparing the event, doing huge load testing. At that time, they were tracking the way the user were placing bets, and most of the user were placing bets through their browser, and few of them on mobile devices. So what they were expecting is that, okay, like we are used to, 99% or 95% of the traffic will be done by browser and few on a mobile. So what happened is that they didn't estimate or underestimate, I would say, the nodes dedicated for the mobile users. So what happens on the first game for the French team? Everyone was placing bets with a mobile device. At the half game, more load from mobile device. And what happened is just the servers just crashed. So no way to place bet anymore before at the end of the game. So that was a disaster. So they lost a lot of potential business, and they made a task force to figure out what happened. And they came to the conclusion that, oh my God, the traffic came from mobile devices. So they had to restructure and add more nodes for the mobile users. So that's exactly highlights the fact that when you do load testing, try to include all your type of clients, because otherwise you will probably miss something, or your results won't be relevant. So when it comes to performance testing mobile applications, there are a couple of challenges. The first, of course, is the device itself. You have different type of devices, different type of operating systems. You have different screen size. You can have different type of apps. It could be native, it could be hybrid, it could be a web-based app. So different combinations, in fact. So this is on the device testing purely. And this device can be connected through a network. And the network will reach your environment, your infrastructure, to deliver the information. So testing the infrastructure, I mean, it's not new. We've been doing load testing so many years. So here, I'm not going to focus on this area here. So let's see the other challenges. The first one is network. So what is the main difference between a desktop user and a mobile user? So desktop user is connected through maybe his Wi-Fi, and then once you get to the carry, and then you go internet. Mobile devices potentially could be in the car, in a train, it could be moving. So first you need to reach the closest antenna, and then maybe your carry is renting lines from another carry, so you have extra bounds to get to your final carry network and to bring to internet. So that shows that you can have more. It takes more impact, the network, compared to a normal user. There is more bounds, more routes to get to the information. In fact, when you look at network, there are a couple of constraints. You got the latency, you got the bandwidth, and of course you get the packet loss. I'll talk about packet loss afterward. So most of the time, when you talk about those constraints, people says, okay, the biggest constraint that will impact my user will be the bandwidth. In fact, this was true 10 or 20 or 12 or 15 years ago, where everyone had bad connections. So by switching to a better ADSL connections here, you will improve the response times. In fact, what is interesting here, there is a I don't know if you have aware of this really good engineer from Google called Igor Grigovic. He made some studies, so he's got a blog. I would recommend to have a look at it. So I just extracted two graphs from his blog here, and it's comparing. He was trying to figure out what is impacting our users. Is it bandwidth? Is it latency? Or is it latency? And what he just showed here is that when you had 1 meg, and then you improved to 2 megs, so better connection, then you had a significant improvement in response time. So that was true. But now if you look at now our mobile connections, most of the people has 4G now, slowly we'll move to 5G, and you can see that the difference between the two networks, they won't have any improvement on the response times anymore. Everyone has proper connections, so won't be any improvement on that area. But on the other sides, if you look at latency compared to response times, you can see that there is a direct relationship between latency and response times. If your latency is increasing, then your response time is increasing. But what is latency? Latency is the time to travel 1 packet over the network. So if I'm based here in Marseille, for example, and I want to reach a server based in New York, then this packet will potentially go to the carry network, go undersea with the lines that has been connected on the sea, and then I will reach probably New York and then the data center. So that's the time to reach this server. So depending where you're based, depending where are your infrastructure based, then this latency could be higher than other users, for example. So the other impact here is packet loss. I mean, we are using mobile, so we are traveling, you're in a train, so potentially you will lose packet during while you're using your app. And packet loss has one impact. It's ask if you're losing a packet, then you need to retransmit the entire network. So it brings more load on your server due to that issue. The other thing, of course, response times has been also impacted by packet loss. So we know that those constraints are important, so we have to sort of measure those constraints and how it impacts our users. And in fact, I mentioned before, we used to change the way our UI, the way we deliver information for our customers, browser-based or native apps, and so our applications are heavier and they are generating more requests. So it's just because our applications are more chatty. They have more chattiness, which means I like to compare old architecture, web app architecture, to me calling my friend to get a beer. So I will say, I will send a request. I will call him. I will send a request. So there will be a question to my friend. I will say, hi, how are you? So one answer, yes, I'm fine. And then I would say, hey, what about take a beer tonight? And he say, yeah, sure, let's meet. So 2 or 3 questions, and that's it. We have our beer together. So didn't have much request. And if I do the same experience with my wife here, calling her best friend, then yes, they're gonna have a beer or a drink. Yes, she's gonna ask how she is and so on. But suddenly, a couple of more questions will be introduced in this conversation. So their conversation is more chattiness. And why do I mention that? I'm not saying that my wife is chatting a lot with her friends. This is not the idea. Here I'm mentioning that we are sending more requests, getting more response with OGs and calls. And every time you got latency, it's been introduced on every network conversation. So if you send an HTTP request, if you're familiar with TCP IP, you will have some CNN hack mechanism, which means this latency will be introduced during every network conversation. CNN hack. So I need to send a request, I will send a hack. I will send a response, I'm going to send a hack, which means potential one request and response is 6 different network conversations. So 6 times your latency. So it's really important to measure that. And what is the impact of those network constraints? I mean, I mentioned latency, packet loss, and bandwidth. But the thing is, of course, these constraints will impact the overall response times, and we're not surprised about it. But more than that, it's going to impact your servers, because those users are slower, which means they're going to stay longer in your architecture. And so if you are longer users, then you will have more sessions. And so more sessions means more CPU, more memory, and so on. So the way your servers are consuming memory and CPU is totally different if you're testing with or without the network. So you need to bring the network here in your testing. Second thing is the devices. I mean, if I know that I'm going to have some Android users, iPhone users, I need to test those combinations. Maybe the way it's rendering on the iOS or the native app for iOS will be different from the Android. So this needs to be, of course, also tested in somehow. The other thing is mobile device is you're deploying a native app on the stores, Google Play, or it could be Apple Store, and potentially any user can download that and start utilizing it. So you can have more users. And people are using their mobile at work, in the train, at home, so you can have spikes at any time. You don't predict anymore spikes related to business hours. And also, if you're delivering, though you have users coming from different geos, it makes sense also because they are located on different areas. Maybe they have more latency to get to your servers. So it makes sense to measure from those locations. So distributed, measure the response time from those locations makes sense. And like I mentioned, a mix of web and mobile users. So how do we resolve that? First, we need to create realistic scenarios, scenarios for mobile, browser, API, so have the whole entire scope. Bring the network in your tests, so measure latency from different carriers, from different locations, and bring that in a picture. And also utilize mobile device. The other thing is, the way we are building our native apps or the way we are building our web applications are based on JSON calls and REST calls, which means those before you get the UI, which is usually delivered at the very last mile of the project, then you can, before waiting and start testing too late, it makes sense to bring the tests as early as possible by testing those REST calls on daily basis, include the test in your CI, get feedback, and also, resolve your performance problems before it's too late, because they're going to be very expensive later on in the project. So here, the idea is bring your testing solutions in the picture in your pipeline. And this is an example where it's of a pipeline where you have the code in Git, you build the app, you do some code analysis, then you deploy your application potentially on containers to make it if you need them just for testing purposes, you can deploy them on containers if required, of course. And then you do those what we call gray box testing by testing the API level to make sure that there is no regression between the latest build of your app or the latest commit of a developer. And then if everything is fine here, we mentioned we need to validate our user experience. It's important. We know it's impacting our business, so let's test it. So that's where I will combine Kobiton for the mobile testing to test the end user experience from the mobile device and make sure it works fine here. And once we have this green light, then I will do the test, end-to-end testing, combining NeoLoad plus Kobiton to have the full picture. So we said that, if you don't test from a mobile device, why do I need to test with a mobile device? Simply because those mobile devices using API call, so JSON calls potentially to get the data that is required to load or render the native app. And if you limit yourself to test only those APIs, then the response times that you measure will be very far from the reality. Here, if you look here on this slide here, you can see that I've been testing my API, and my API were around 0.5 seconds. All right, it's wonderful, awesome response time. So let's go to production. And if I look at the real user experience of the same transaction, but on the UI of the mobile of an Android phone, for example, or an iPhone, for example, you see that I'm facing to 10 seconds or 7 seconds, which is nothing compare to the REST call or to the JSON call. So that's why testing with a real device will allow you to see what is really happening, and include that that's rendering time that is not included in the scope of load testing if you limit yourself only to the API.
Thank you, Hendrik. Yes. So these are the results of a survey, and Hendrik's spoken about the importance of testing on real devices. This is a survey that Kobiton did this year and asked a statistically significant group of people, of testers, the importance of testing on real devices. And this is, it's quite telling and consistent with what we've seen in the industry, that people feel like it's crucial or very important. You know, we have over 85% of the respondees tout how important it is to test on real devices. And I'm going to explain how important it is not just to test on real devices, but also to test on those devices geographically distributed, as well as while the server is under load. So this For those of you who know what a race condition is, a race condition is one of the issues, as Hendrik was describing, the communication between the mobile app and the server. When you're in your test environment or in your development environment, when you're not executing under load, you may not see where messages come back at the unexpected order that they were sent in. So you anticipate packet A and packet B to come back in that order, but when the system is under load or it's you have a slow network, it may come back in the wrong order and cause some adverse conditions to your app. And I'm going to talk through an example that actually happened yesterday with one of our customers and how we helped them solve their problem. So the impact, though, is, in the case that we had with our customer, was their application was crashing in certain conditions, in certain situations. The other risk is you might expose security vulnerabilities. We've heard about some of the issues recently with race conditions on chipsets. These can also happen in your mobile apps. And then finally, probably one of the most troublesome issues with race conditions is data corruption. As more and more of the processing, as Hendrik referred to, more and more of the processing is done on mobile apps on the device. The devices are getting more and more powerful. They have more and more storage. And there are technologies like Google's Firestore that allow for local storage that's in beta right now, will allow you to store more data locally and handle offline scenarios. Well, you also have to worry about, in race conditions, multiple threads of your application trying to write to the same data store and ending up corrupting the data. And those are tricky to figure out because you don't know exactly where it's happening when you get to a production environment. So the scenario that we had that came up last night was one of our customers. Their app was crashing sometimes, but not all the time, and it was really hard. It was a race condition. What was occurring was they were going out to use location information from the Google Play Store prior to asking permission from the user. So in some cases, when the system was not under load, the order that when they're in their testing environment, the order that they were going through, they were able to launch the request to the user. The user said yes, and then by that time the response came back and everything worked fine. When the system was under load, the order of operation was switched. So they were getting a response back from the Play Store without the permission from the user, and it was not rendering. In some cases, it was on Android 6, 6.0, it was crashing. On Android 7, it was not crashing. So we were able to take the logs from Kobiton and analyze, give those to the customer to analyze exactly why it was occurring in certain situations and not others. Great example and very current example of why it's so crucial to test on real devices and while the system is under load. So this is a report that I wanted to explain. When you're dealing with real devices, it's important to identify anomalies. It's important to understand when you're executing across 50 devices within the Kobiton cloud, which devices are causing problems. Your users are experiencing it. They're not all using the same device type. They're not using all the same operating system. So understanding how your application is performing in each of those steps in the application. So you can, with Kobiton, you can see while you're running across these 50 devices, what's the average response time? Those are those gray circles in the middle. What's the average response time for each step in your application? And then what are the, how much variance is there? The plus or minus 1 standard deviation is the above and below that, the circle, the gray circle in the middle, the ticks above and below. And then for this specific device, as you can see at the top, this report is for a Nexus 5. Where is that specific Nexus 5 most problematic? And you can see on this one that at the innovation warm-up step, that it's not just, it's taking 15 seconds to respond in that step. It's well above the standard deviation, and it's, at this point, users are going to get quite frustrated with your application. So being able to identify and isolate not just general performance anomalies in your application, but performance anomalies, response time anomalies on specific devices, because each device and operating system is going to behave differently. The other important point here is with Kobiton, this is a screenshot of Kobiton, and this is the application that we were working with where the application crashed. You can see a full video of what was happening leading up to the crash. You can see the logs that were spitting out from the application at the point in time that the application crashed. That's why we were able to isolate the root cause of the problem for our customers so quickly. We had real device output while the application was trying to communicate with the Google Play Store, as well as when it was asking for the user permissions, and we were able to see that quickly. You can see the steps that the user took. You can see over here where that red dot is. That's actually the action that was performed by that user on the device. And you can see the video and the actions performed in the logs, all through our session output. The one Kobiton offers a lot of unique capabilities that are different than our competitors. One important point that Hendrik talked about that I wanted to touch on in more detail was the geographic distribution. Any of the users using Kobiton as part of your organization can connect real devices into the Kobiton cloud, so we can capture all of that deep, rich information. The video, the actions, the response time, the logs from every device that you connect to your cloud all around the world. So you could have users in the Middle East, users in South America. If you've got your server sitting in AWS in the US and you want to see what does a user in Brazil, how do they see the application? What is it like to use your application from someone in Brazil? What is the response time? How do they feel? And you can see that any one of your users can connect to, or any one of your testers can connect to the Kobiton cloud and have distributed testing all around the world.
So here, before I show the integration as it is, I'm just going to remind a couple of things related to NeoLoad. NeoLoad, of course, can record, from any type of device. So it could be a browser, or it could be a native app, whatever it is. And then because we mentioned, we will simulate the way the device or the browser is sending the request, but we are not behaving like a browser. We are not behaving like a mobile device, which means this rendering time that we mentioned won't be measured in the output of the response times. Of course, we have added the one emulation embedded in our load emitter. So either you use load from your on-prem on network, so it's going to be on-prem load emitter. So those will have, of course, the one emulations available. So you can simulate the users with different kind of network conditions. And then, if you want, you can use also the load generator based on the cloud. So we have a cloud platform where you can generate load from there. And of course, like most of the load testing solutions of the market, you have the ability to monitor and retrieve metrics from the infrastructure to understand what's happening. So how do we combine and use Kobiton here. And we mentioned we need to measure from a real device or from a device reaching the web. So to do that, I'm going to use Kobiton. So NeoLoad will generate the load, and in parallel, we will command Kobiton to execute some scripts, so automation testing on a real device. And once we have validated one step, we will get the in live, the different response times, the different timers that has been measured on a real device. So the idea is, of course, I'm not going to use Kobiton to make the load test itself, because it's going to cost me a lot, or it's going to be very hard to manage. I would say if I need to spin up 5,000 devices, I could technically do it, but to gather all the reporting and so on will be quite complex. So the idea here is I'm going to use NeoLoad. So NeoLoad will generate the load. So 99% of the load will do done through protocol level testing. So that will make the stress on the application server. And in the top of that, I will launch a couple of users on real devices based located in managed by Kobiton, and they will report back my user experience. So the idea is, before we get to the Q&A, I would like to show you. I made some tests today. So how the integration works. The first thing, the idea here, I got this Eclipse project where I've prepared some tests for my application. It's a native app for Android. So the way I'm doing here is traditional Selenium that will be running over Appium. So I'm using the Appium driver. The only thing I'm doing here to make this test available and connectable with NeoLoad is I'm using one of the NeoLoad's Selenium wrapper. So NeoLoad Selenium wrapper is compatible with Appium and a traditional web browser testing. So here, what I'm doing here, I'm importing this through Maven, the Neotys wrapper. And the only line I'm doing here, so here I define the fact that I'm going to use an Android driver, and then I'm passing that to the NeoLoad Selenium driver, which says here I get the Android driver as a parameter. I'm pointing to a NeoLoad, and then which means I can then take advantage of the scripts and it will be ready to be used for load testing. The only thing that I need to do, especially for mobile, I need to define what I would like to measure. So I'm defining my transaction. So here I got a start transaction, I got a stop transaction, and this is how I'm measuring the timers that I want to report back to NeoLoad. Then in my project in NeoLoad, of course, I have my traditional users that will browse and reach the applications. I have the similar user for the mobile, so it's going to be basically one API call here, which is correlated. And what I did here, I added one user for to trigger Kobiton. So I'm calling my Kobiton scripts. I have passed a couple of parameters. So I'm managing the data sets of the scripts through NeoLoad. So here I'm passing those parameters for the scripts in this action here. And then I just have to define a test, which is a combination of users plus, of course, the Appium scripts that will run over Kobiton. If I look at the results at the end, what I would have is, of course, all the traditional KPI delivered by NeoLoad. So response time, hit per second, throughput. But here in the external data tab here, I can see that I got my timers back. So I can basically look at this response times and see how it behaves here during the timeline of the project from a real device. So that's what's going to happen in NeoLoad. You will have the response times there available. What is interesting is what would we have in Kobiton? So Frank mentioned here, so this is my Kobiton session here, which is Kobiton's website. I can see all the devices available. And every test, or every time I have a trigger test in Kobiton, you will have that in the session. And I can see that, yes, the test I was showing was the test of Monday. So I can click on one of those execution here, get the details. And moreover, if something was bad at that time, I can have a look at the video directly and see what happened and why did that user had this bad user experience. So the video will help me to understand that aspect. So this is a really short overview of the integration. You can see that basically the traditional SIEM wrapper make this integration possible, and you can then take advantage of using Kobiton, which is a really efficient and cost-effective platform. So if you want to do load testing mobile application without impacting your project, you can easily do it by combining NeoLoad and Kobiton. All right, so that's it for the demonstration. Do you have any questions so far? So Drew, I will leave you do the moderation of the Q&A. I see that there are a couple of questions available.
Yeah, Henrik, it does look like we have quite a few questions actually. So we'll go through some of them, and hopefully we can follow up later after the webinar for some of the ones that may or may not be answered. So first things first, it looks like if my users are geographically distributed and I want to test with real devices, how practical is it?
Yes, you want to, I can take a first stab at this, and Henrik, you can tag on as well. So from a technical perspective, it's very practical. From a user, so finding testers, there are some services that are available where you can use testers in geographically distributed locations to test against your application. That we have a very easy way to set up those users across those different geographic locations. So if you wanted to send an email to us, we can put you in contact with those testing providers that provide users or testers who are just geographically distributed. Drew, where would they send that email to?
You can go ahead and send it to support@kobiton.com.
Great. And
so for the load perspective, like I mentioned, I mean, your user based, depending on the geos, the latency, the network conditions will be totally different. So it makes sense to test from those locations to make sure that, including the network, do are still able to deliver proper user experience. The using of the Neotys cloud is really easy. It's one click, you spin up machines over 57 different geos, so it's not impacting, that doesn't require special things. You can even automate that with Jenkins, by the way. So, and then if you want to use different device from over the world, you can of course utilize Kobiton with the current offering. Any did I answer your questions? Or maybe, I don't know if, yeah, you answered it. Okay. Do you have any other questions?
Drew? Drew?
So there's another question. I think it's so are you saying that Kobiton has devices available for testing in various global data centers they control, or
Yeah, so this is it's difficult to understand this, so I'm going to just explain it. It's really hard to grasp what the technology does. So you can plug your a mobile device from Germany connected to a MacBook, and that will register into the Kobiton cloud. So when you run tests on that mobile device, after it's been connected into the Kobiton cloud, you will see the actual response time as if the requests were coming from Germany. You would be able to get full video of the requests as they were coming from Germany. We have our data. We have 2 data centers in the U.S. right now. We will be opening data centers internationally, but to do distributed testing with Kobiton, you don't need to use our devices. You can use your own devices or third-party tester devices that are connected into the Kobiton cloud. It's a very unique capability of Kobiton that nobody else can provide.
I think there's another question quite similar. It's during development and testing application. The application is only available on secure network or protected network. So how can I test real devices if Kobiton Cloud cannot connect to that network? So I guess you partially answer it through by using your own device that will be connected to your platform. But do you have also other options for that?
Sure. If you you can connect, as you mentioned, Henrik, you can connect your own devices into your local network. We also have a variety of ways. If you wanted to connect to a set of private devices that we manage for you, you can connect via VPN or proxy into your private network, so that you can have a secure access into your development and test environments.
There is another question that says, you told us that 25% of users will have lower opinion of our brand if battery usage is high. Where do I see the current consumptions of the CPU or RAM battery usage?
Yeah, so we are within the release that's going out this summer. You'll be able to see the CPU utilization, memory, network, and battery usage of the device from the log. So you'll be able to query the logs that will give you this information.
But more important, I'm adding my own question. Sorry, I didn't type it, but I'm adding my question. I guess if you're providing this, would we be able to correlate? Let's say I've been doing this transaction login, and I wanna get sort of the CPU usage of that actions. Would that be possible?
Yeah. So, and what we'll do, similar to the report I showed earlier, we'll be able to run that against 50 devices or however many devices, look at the average across all those devices for that step in the process, and then look at the plus or minus 1 standard deviation. So you'll be able to know where in your application certain parts of the application across specific devices are causing problems. And you'd also will have some industry data to be able to compare that against similar applications. For example, if you're using video streaming in your application, you know, how performant or how much CPU utilization do you have compared to other applications of similar genre.
Okay. I'm just looking, so I think we're going to answer the two last questions, and then if we didn't answer, we will normally have your email, so we will try to get back to you for the answers. One is the video part of the NeoLoad reporting? So at the moment, with this release of this integration, the link of the video is not reported back in NeoLoad, so you have to figure out the timeline when you have the issue to get to Kobitons and see the video. But this is something that we agreed makes sense to provide the link in NeoLoad, so you can just click and see directly the what happened on that specific user. And the other question is, I am from for Argentina, working for a San Francisco CA-based e-commerce website. What if I want to perform load testing on real devices from here? How to dismiss the latency between Argentina and the US? So here, I will answer for a NeoLoad perspective, and I will leave you a frank answer for the Kobiton. So here, in NeoLoad, in the previous scheme that I just showed, I'm going to go back here. You can see that the architecture of NeoLoad, there is the controller that will sit in your case in Argentina, and then you will use load generators. Load generator is the component that is used to generate the load. So this load generator could be located in San Francisco, if you want to generate the load from San Francisco. So it's just one server without any UI. You can install it or use cloud-based machines, and then you will apply the one emulation. So even if you're in Argentina, by the way, you can simulate the similar latency from NeoLoad by configuring the emulation in NeoLoad. Frank, for you.
Yeah, I think just to add on to that, you can look at the timing. If you run your tests from a device connected to Kobiton from Argentina, and you run the same test simultaneously from a device in San Francisco, you'll be able to look at the time difference to understand. If you can do that while the system is under load, and you can also do that while the system is quiet, and you can see that 2x2 comparison to understand what factors are contributing to the response time both from Argentina and San Francisco under load and not under load.
Okay, so I think it's we've over we are 5 minutes over the expected end of the webinar. So I think it's time to finish the webinar. So I would like, first of all, thank you everyone that had the ability. Yes.
One last thing. There was one last question I thought was a good one. Is are you going to make the code that you've developed on the integration publicly available?
I mean, yeah. I mean, we could imagine to post that on GitHub.
Great.
So you could at least have an example. By the way, for those who's familiar with NeoLoad, I was using the sample application, which is the sample project available in NeoLoad by default. So you can easily replicate that. So you just have to get the Eclipse project to test that for sure.
Okay, sorry.
All right, so I think I would like to thank everyone to attend this this webinar. So for those who didn't have the chance, you will of course get the recording. I would like to thank, of course, Frank for his time and his great presentation. Thank you, Frank.
Thank you, Hendrik. Really appreciate it.
And thank you, Drew, for the introduction. So I would like to, so we will close the webinar. Have a great end of the day, great afternoon, depending where you're based, and see you soon. See you. Bye.
Thanks, everyone.